Hello everyone, myself Bandgar SS, working as assistant professor at Department of Physics, KTHM College, Nasa. Today we have going to discuss M.Sc second year paper 3 semester 3, that is subject of experimental technique in physics first. We have to cover the first chapter, signal analysis and sensors. So today we have to cover the second part of the classification of the sense. First model is signal analysis, sensors. Now next parameter for sensing, next physical parameters by sensors, and use the some different examples. First one is the tachometer. It is the device is used for reading the speed of vehicle wheel rotation. It is usually consists of a toothed ring and pickup. A tachometer is also called revolution counter, tach, V counter, RPM gauge. It is an instrument measuring the rotation speed or shaft or disc as a motor or other machine, as well as it is display the revolution per minute on a calibrated analog dial. But digital display are increasingly common. So tachometer is used for to measure a speed, position of the wheel of vehicle or motor. Second example of the speed and position, it is the linear variable differential transfer. It is the common example, or everyone knows what is the LVDT. It is a device, or it is a type of transformer used linear displacement or position. So it converts a linear displacement into a electrical signal through a principle of mutual induction. So everyone knows what is the principle of mutual induction. So it is the transfer the energy from one coil to the another coil, that is the known as the mutual induction. Third example of the speed and position is the variable reluctance, which is provide a linear velocity, angular velocity, position, torque. These are the parameters measured by the variable reluctance. By using measure the changes in a magnetic reluctance, detect the change in presence or proximity of ferrous object. The measurement is made from the voltage induced in surrounding coil as the magnetic mass moves under the influence of an acceleration. So using a variable reluctance, you can measure or provide the different parameters like as position, torque, velocity, like as angular, and like as linear, by changing the magnetic reluctance. Next, piezoelectric accelerometer. It is the measure dynamic change in a mechanical variables like as acceleration, vibration, mechanical shocks. The force exerted on the piezoelectric material can be observed in the change in electrostatic force or voltage generated by a piezoelectric metal. When we apply a force pressure on a piezoelectric material, so there is change in a electrostatic force or voltage is known as the, or it is the function of the piezoelectric accelerometer. Next example is the linear encoder. Linear encoder is a sensor or transducer or read head paired with a scale encodes the position. The sensor reads the scale in order to convert encoded position into a analog or digital signal, which can be decoded into position and the it read by digital readout or monitor control. Next is the odometer. Odometer is the also an instrument or device to measuring the distance traveling by a vehicle, bicycle, car. The device may be electronic, mechanical, or combination of both. Electromechanical means combination of electronic and mechanical. Next parameter is the light. Measuring parameter is the light, which have two different examples, but we have to see in the sum of them. So starting with photo detector, I think everyone knows the photo detector. It detects the photons, that is known as the photo detectors. It is also called as a photosensors. It is a sensors of light or electromagnetic radiation. A photodetector has a PN junction, converts light photons into current. The absorbed photons make electron-hole pairs in the depletion region. Photodiodes and phototransistors are few examples of photodetectors. Solar cells converts the solar energy absorbed and convert into a electrical energy. So these two main examples, photodiode and phototransistor, are used as a photodetector. Next, photoresistors and LDR. Photoresistor, it is the short form is the LDR. It is also known as the light decreasing resistance or light dependent resistance or photoconductive cells. It is a passive components that decrease the resistance with respect to receiving luminosity or light on the component sensitive surface. So when the light intensity bombarded on the surface of that resistor, so the change the resistance, increase or decrease the resistance with respect to light intensity. When light intensity is more than resistance of photoresistor or LDR is the minimum. When light intensity is maximum, then photoresistor LDR resistance is minimum. So it exhibits the photoconductivity. Next example of the light is the light emitting diode LED. This capability may be used in a variety of applications, including ambient light detection and bidirectional communication. It is sensitive to wavelengths equal to or shorter the predominant wavelength. It emits various colors. So light emitting diode act as a sensor. So it performs the various colors light wavelengths. So it is used for the various communication. Thermopile is also used in a light sensors. So it is the thermocoil as a laser sensors. When incoming radiation of the lasers is converted into heat energy at the surface, the heat input produces a temperature gradient across the sensor. Making use of the thermoelectric effect, the voltage is directly to the incoming radiation. It can be directly related to the radiation power. So whatever radiation coming from the laser, it is the bombarded on the surface of the material. So that materials produce a heat. So that heat or that radiation pattern is generated in the voltage across it. That is the working of the thermopile and laser sensors. Next is a gas sensors. So we have to use different examples, or we have to measure a physical parameter as a gas. So we have to different types or different sensors are used to measure a gas, or they are operating on the gas. So first one is the electrochemical. So electrochemical gas detector, it is the working allows the gases to diffuse the porous membrane to an electrode where it is either chemically oxidized or reduced. The amount of current produced is determined by how much of the gas is oxidized at the electrode, indicating the concentration of the gas. So it is the how much gas we have to passing through that, and they are chemically oxidized or reduced. So there is amount of, or there is amount of current is produced, or that is the determined by a electron. So that is the known as the electrochemical sensor. So next one is the ultrasonic. So they detect the acoustic emission created when pressured gas expands in a low pressure area through a small orifice, the leak. So ultrasonic gas sensors is used for to detect the acoustic, means when some gas is leaked at a low pressure, when a pressure gas is expands. Next one is the holographic gas sensors. It is a light reflection to detect change in a polymer film matrix containing a holograph. So holograph containing a polymer film matrix, when we apply a light on that, so there is changes detection. So that is the holographic gas sensors. Then next one is the photo ionization gas sensors. It is also known as the PIDs. It is used photon energy UV lamp to ionize chemicals in the sampled gas. Next one parameter is the humidity. So we have to know the different examples of humidity sensors, like as a capacitive humidity sensor, resistive humidity sensor, and thermal conductivity humidity sensor. So starting with first capacitive humidity sensor, it is the simple capacitive RS sensors can be made from an air-filled capacitor as the moisture in the atmosphere changes its permittivity. So it is the compare with a air-filled capacitors, its changes from the moisture atmosphere moisture changes its permittivity. Next one is the resistive humidity sensor. Resistive humidity sensor is usually made of materials with relatively low resistivity, and this resistivity changes significantly changes with humidity. So there is when humidity changes, atmospheric humidity changes with that device, so there is the resistivity changes of that device. So that is the resistivity humidity sensors. Next one is the thermal conductivity humidity sensors. So the resistance of the thermistor is calculated, and the difference between the two values is directly proportional to the absolute value. So there we have to use two thermistors. They are negative temperature coefficient thermistor. When they kept in a atmosphere, and you will get the two resistance. So that is the difference between the two resistance. We have to calculate the thermal conductivity of humidity sensors, or you have to calculate the humidity by using this difference. Next one is the mechanical sensors. So mechanical sensors, same as mechanical sensors, has many examples, but we have to see the sum of them. So starting with a first piezoelectric. So piezoelectric sensors, it converts the mechanical mechanical parameter into a electrical signals. So a piezoelectric transducer is also known as a piezoelectric sensor, is a device that uses piezoelectric effect to measure changes in acceleration, pressure, strain, temperature or force by converting this energy into an electrical charge. So means whatever parameters, mechanical parameters converted into electrical form. So that is known as the piezoelectric sensors. Next one is the tactile sensors. It detect the position or measure the position of any device object. So detect and measure the spatial distribution of forces perpendicular to a predetermined sensory area and interpret the spatial information. So it detect or gives the position of the any object or device. Next example of mechanical sensor is touch sensors. So it a device which measures the parameter to conduct between the sensor and object. When we touch any device or a sensors, so there is generated a conduction. So that conduction contact force at defined point you have to apply. So then there that contact generates a conduction. That is the principle of the touch sensors. Next one is the radiance sensors. It has two examples. First one is the optical pyrometer and second one is the thin pyrometer. So optical pyrometer, it is the measures the heat radiation, or thin film parameter, it is the measures the hot gases radiation. So optical pyrometer, it is a principle that the intensity of light received by the observer depends upon the distance of the observer from source and temperature of distant source. Second, the thin filament pyrometry. This technique involves small solids in contact with hot gases. A thin filament in hot gases stream, the radiative emission from the filament can be correlated with filament. Next is a chemical sensors. We have to give the two examples. First one is the smoke detector and second one is the electrochemical gas sensors. So if any smoke particles enters the open chamber, some of the ions will attach the particles not available to carry the current in that chamber. An electronic circuit detect the current difference have developed between a open and sealed chamber and sound the alarm. When consider we have to take two chambers, one is the open and another is the reference chamber or sealed chambers with reference gas. When some smoke particles enters in a open gas chamber, so there is comparison between them, and by using a electronic circuit and generates a current, and you will get the sounds of alarm. So there is some smoke smoke is available in that air by using a smoke detector sensor. Next one is the electrochemical. So it converts the chemical energy into a electrical energy. So it detects the gas chemicals present in there and converted into a electrical signals and gives the output. So electrochemical gas detectors work by allowing the gases diffuse through a porous membranes or to an electrode where there is where it is either chemically oxidized or reduced. The amount of current produced is determined by how much of the gas is oxidized at the electrode, indicating the concentration of the gas. So we have to already seen that example in a gas sensors. So that is the we have to detect by a electrode and convert it into a how much current, and you have to detect the that chemical or gas. So that is the electrochemical sensors. And last one is the magnetic parameter we have to measure. So we have to use a different magnetic sensors like as examples Hall effect sensors and magnetic anomaly detector. So first one is the Hall effect sensor. It is a device that is the used to measure the magnitude of the magnetic field. Its output voltage is directly proportional to the magnetic field strength. So when we measure a magnitude of magnetic field, that time we have to use a Hall effect magnetic sensors. And next one is the magnetic anomaly detector. It is a instrument or device used to detect minute variation in the earth magnetic